Okay, now I am on page 8, example 4. So this is again from chapter 14, okay? All right, so let's read. This is a long one. Hoping to lure more more shoppers downtown, a city builds a new public parking garage. They plan to pay for the structure through parking fees. During a 2-year period, or 730 days, a random sample of 44 days, so that's my sample information, of daily fees were collected. So that means that this extra number right here is the number of days in the population. That number is there only so that we can check if our conditions have been met. That's for the 10% condition. Let's keep reading. It says the mean of the sample was 126 and the standard deviation was $15. A consultant predicted the daily average income would be $130. So that's predicted. So that's just a guess. Construct a 90% confidence interval to determine if the consultant is correct. Okay, so let's go ahead and check the conditions and then we'll make our interval. So the conditions here first begin with, I'm going to use abbreviations, but independence / randomization. So if we look through our paragraph, it says this was a random sample. So this condition was in fact satisfied. My video just quit on me for some reason. I hope it's all good. All right, we're going to jump to condition number 2, which is nearly normal. And this relates to whether or not our sample size is larger than 30, so we can claim the central limit theorem was met. So in this case, the 44 days we sampled is in fact greater than 30. So the central limit theorem applies, and this is a normal model. And then our third condition is the 10% condition. And the question is 44 less than 10% of the 730 days that we surveyed? And the answer here is yes. 10% of 730 would move the decimal place over once, and we would get 73. And 44 is definitely less than 73. Okay, so we've met our conditions, which means we can now construct a confidence interval for the mean fees collected daily. So this means we're going to go to our calculators and go to, it helps if I can spell it, go to the T interval. All right? Now remember that we have a choice of data or stats, and in this particular example, I am not provided with any data. So this is a stats question. So we are going to need to pick out the important stats that go into our calculator. So we need X bar, SX, and N. And I'm going to write our confidence level down, and I'm just going to remind you that when we did this back in chapter 13, we put that as a decimal. That's the last number that we enter in our calculator. So our mean for our sample was $126. The standard deviation was 15, and we sampled 44 days. So we go into our calculator, go to our T interval, and run this interval. Let's put our output right next to it. We can interpret the interval and answer the question right below. So my output is 122.2 and 129.8. So let's interpret this interval. We are 90% confident the mean daily fees fall between, let's put this into dollar amounts, right? $122.20 and $129.80. And then it says, was the consultant correct that the daily average would be $130? And now this is that question of, does the value provided fall within the interval? They said it would be $130. Our interval is below. Our entire interval falls below $130. So the consultant is not correct. Okay, remember, this person's one job was to say we would definitely make $130. And our confidence interval at 90% says we are under. So that means that they didn't perform their job. So this is why we would use a confidence interval in real life. Excuse me. I'm going to follow up with one more example, and we're going to apply this with data.